Okay, number 4 from page 378. This is part of your review. Today's December 19, 2011. It's chapter 6 review. The question is a word problem. It says sketch 3 cycles of a sinusoidal function that has a period of 360 and amplitude of 3, and whose equation of the axis is y equals -1. So I'm going to write down the imperative information they gave me. They said the period of this function, so one period was 360 degrees. They want me to graph 3 cycles, or in our case 3 periods. The amplitude was 3. And the equation of the axis, so EOA, was equal to y equals -1. Okay? So this is the information they've given us. We need to create a graph of this function. So what we're going to have to do is what's very important. We know it's going to start at 0. If it takes one period 360 degrees, how long will it take for 3 cycles of this? How would I figure that out? I need to multiply those two numbers. So I'm going to take the period times the cycles. Period times cycles. That's going to give us our timeline. Okay? So our period was 360 degrees, and it was over the course of 3 cycles. So the timeline, or however long this is going to last, is 3 times 360, which is 1,080. So we're talking about 1080. Any of you guys are snowboarders? True. 1080 degrees, okay? So that means on my x-axis, I have to make sure my graph starts at 0 and will at least make it up to 1,080 degrees, okay? The period takes 3, did they say? It's also a sinusoidal function. So we're talking about our sine wave here, a sinusoidal function. Yeah, sinusoidal function. Okay? So we need to create our graph. The other thing, actually, before I even start to create the graph, I have an amplitude of 3, and I have an equation of the axis of y equals -1. So I got to figure out what my peak and my trough is going to be. And in order to figure those out, the peak will be equal to the amplitude plus the equation of the axis. Okay? No, this is just for the peak. And your trough will be equal to the equation of the axis minus amplitude. Okay? You know what? I'm going to reverse the other two so it looks a little more similar. So we're only dealing with a positive and a negative sign. So it's the same as the equation of the axis plus the amplitude. Because our equation of the axis is the middle of our sinusoidal function. So in order for a peak, equation of the axis was our -1, and the amplitude is 3. So my peak is equal to what? 2. So that's the highest point. Our trough is -1 minus 3. What's the lowest point? -4. -4 is our lowest point. So we've got some pretty imperative information here. This will help us when we make our graph because we know our y-axis of the graph has to go at least as high as the number 2 and as low as the number 4 in order to encompass all the numbers. So to figure out our peak and our trough. The opposite of what? Okay, so we go to make this graph. We know that one period is 360. We got to get it to 1080. Okay, so let's count how many squares I have here. 1, 2, 3, 4, 5, 6, 9, 10, 11, 12, 13. If I do 1080 divide, let's say if I went up by 90s, that's 12. Then I have 13 spaces, so that'll work out perfect. I'm going to go up by 90 each time. 180, 270, 360. Plus another 180 is going to be 540. Plus another 180. Yeah, you're going to have to be drawing these.
You have to make your own graphs?
Yep.
Give us the graph. Ridiculous.
1080. Perfect. So this is our x-axis, which is measured in our degrees here. Our y-axis, we said that the highest point was 2, and the lowest point was -4. I have 4 points, so we got -1, 2, 3, 4, 1, 2, 3, 4. So we have our points. Okay? Now the equation of the axis was that y was equal to -1. So in other words, we have the middle of this goes through here. Okay? That's the middle of our function. We also know that its highest point, that an entire period takes it 360 degrees. So if we're starting here, it takes us 360 to get back here at the same point. The amplitude is 3. Okay? So if our amplitude is 3, I got to go up 3 points from the equation of the axis. 1, 2, 3. Okay? So I know at 90, I'm going to be at the number 2. At 180, I'll be back at -1. Then I go down 3 to find the trough. 1, 2, 3 gives us -4. So at 270, I'm at -4. What's important that you guys realize is there's essentially like almost 5 major points. Our starting point, our peak, when we're coming back down, our lowest point, and when we get back to the beginning again. Okay? So here is one period of this function. So we have our points. We have 1 cycle. The question is asking us for 3. Exactly. This is repetitive. We go up. So 90 degrees over, we go up to 2. 90 degrees over, we come back to -1. 90 degrees over, we're back at -4. 90 degrees over, we start our starting point again. So this is 2 cycles. And finally, exact same thing. So here is our 3 cycles of this sinusoidal function. So we're going to break them all up so that's a little easier to see. This was 1 period, 2 periods, 3 periods. Let's talk about amplitude was 3. From the middle to the highest and the lowest points were 3. Our peak was the number 2, and our trough was the number 4. Exact things we'd written in the question. So, let's now say that the original function was y equals sine x. Okay, that's our lesson 6.6 we were doing the other day. I want you to make an equation of this transferred equation. If you guys remember, our original starts at 0, 90's 1, 180, 270, 360. That little blue line that's about to disappear is what our normal sine wave looks like. Now, we need to put it into reference here. We have our f at x, or y, is equal to, we have an a value for sine, we have an h value, and we have a k value. Okay? Does anyone know what our a value is technically going to be? The amplitude. That's exactly right. So what was our amplitude? 3. So right away, I know my a value because amplitude is 3. A equals 3. So I have that piece of the information. Now, has this one been shifted up or down at all? No. Sorry. Has it been shifted up or down at all, the equation of the axis? What's the equation of the axis of the original function? Original one. 0. What's the equation of the axis of this one? -1. So because it's -1, That means we've shifted down 1. Yeah, so what this is our EOA in this question. Our equation of the axis is actually our K value. The EOA, which is at -1, is equal to our K value, which is -1. Okay? So we have -1. We know this function's gone down. Now, has this function shifted left or right at all? No, it hasn't. So essentially, it's 3 sine x, and I'll move the other part over, -1. There is no h. The h value would be considered 0 in this question because it hasn't shifted left or right. So the equation of this, if this was originally a sine function, is 3 sine x minus 1. H would be shifting left and right. Now remember I told you this was a bit arbitrary. We could have said it maybe started at 2, went like this, and came up. It could have been something like that, right? And in which case, it would have looked like, here's our equation of the axis, and it's actually heading downwards, okay? Normally that's at 180. So we've shifted back 90 degrees. So we've shifted back 90 degrees. So in that case, our h would be positive 90. We've shifted to the left 90 degrees. Does that idea make sense to you? This function is about 90 degrees behind where it normally is. It could have had a different look too. It could have, now there's 2 ways we could have described this. Your questions won't be this arbitrary on the test, but I want you guys to start thinking about this. I could have had a function that looked like this. What would have that been? Yeah, we could have made a negative, or it could have been a shift that is 180 degrees to the right or to the left. Okay, right and left transfer, when they transfer back and forth, it can be arbitrary on how you want to put them. Because if this was transferred 180 to the left, so watch, my 360 is now there, and I'm heading up from that point, and then going down. So if you look, it ends up being the opposite, which could also be a negative a. Don't worry, it won't be that arbitrary on the test. I will be very specific on what we're going to give you guys. But I want you guys to realize h is very arbitrary if you're looking at a graph. That part makes, I know that part's a little difficult. Question number 12. It says the height of a Ferris wheel is modeled by this function. They're given to us h theta is equal to 6 times sine theta minus 45 plus 7. Where h theta is the meters and theta is the number of degrees the Ferris wheel has rotated from the boarding position of the rider. Okay. So, theta is what we've really been calling x. Theta. So, if you would like, you can rename this question h at x because that's our variable. Okay. So we have sine x minus 45 plus 7. Okay. Now, we need to make sense of this. H and x, they use the letter h because they're talking about height. We normally call it f because it's a function. Those letters usually indicate something. So what they're saying is if I were to plug in a value for x and work everything out, I would get my height at that point. Okay, that's just like a y and an x. Okay, so we can replace the h at x with y if we like. So we could have y, because when we draw this on a graph, that's going to be our y-axis, the height. Y is equal to 6 sine x minus 45 plus 7. Now, I need to relate this to our sine wave with our transformations. Okay? So we have our a variable. We have our h variable. Yep, and we have our k variable. Good. So what is my k in this equation? 7. What is my h? 45. Yeah, you could say it's moving to the right, 45. And our a is 6. So we need to graph this function. Give me one quick second. What we're going to do in this question is there's a part A, B, C, and D. I'm going to go through them all at once. I need to figure out how large to make my graph, okay? So, in order to make this graph, I need to graph this function. The last question says they want to know when it's at least 400 degrees, okay? So that means I'm going to have a graph that's going for a while. And what will help us in drawing this is I want you guys to look at it. I have an H transformation while I'm drawing my x-axis of 45 degrees. That's kind of in between what we're used to drawing. We usually do something like 90 degrees, okay? 45 is about half of that. So I'm going to go every 2 slots at 90, okay? Just so I can put 45 nicely on this. So each of these squares represents 45. So at 45, this one is 90. We start at 0, right? 45 again, 180. 270, 360, 45, 450. Beautiful. So that's over our 400. This is good. We can start with this. Now, remember our original one, we go up also. We go up 7 in this one. Oh, shoot. I'm going to have to make this a lot bigger. Because this goes up 7, I need my y-axis to encompass quite a few numbers, okay? It also has an amplitude of 6. So I'm going to tell you right off the bat, the highest point of this is going to be 13. Wow. So looking at this, I might want to shift some things around on this graph. Okay, so in order to graph this, what I'm going to do is I'm going to have my starting point, just so I have a reference, okay? We knew that our graph had to go up to 13. So we know our graph is reaching 13. The original function has a height or a peak of 1 and a trough of -1. So our original function starts at 0. At 90, it's at 1. 180 is at 0. 270 is at -1. And 360 is at 0 again. So this is an original sine wave in terms of our graph. Now our graph's going to look much different from this. Instead of drawing all 3 different transformations, I'm going to talk to you about them. I'm going to put the final one up so it doesn't get too confusing. First off, our amplitude. Our amplitude is 6, which means our 0 points will be the same because when I multiply those by 6, they still stay at 0. When I multiply 1 by 6, I go all the way up to 6. And when I multiply -1 by 6, I go down to -6. Obviously, it doesn't fit. So it would have something that looks like this. That would just be stretching it. That would just be A. Okay? Our K says it goes up 7. Okay? So this point here, let's say I had to move each point up 7. So instead of being at 0, I'm at 7. 1 is at 8. 0, 7. -1's at 6. And 0 again. So this would be a shift of 7 upwards. And finally, -45 means I'm moving everything to the right 45. So my 0 starts here. Okay? My 1 goes there. 180's here. 270 and 360. So it looks almost the same, just shifted to the right a little. Okay? So those are 3 transformations.
I thought it went up to 13.
It does. We're going to put them all together now once so I don't make the page too messy.
So what's the black one?
In the sake of what we're doing right now, I'm going to quickly do this. I'm going to start with my H. My H is to shift everything 45 degrees. So, you know what? We'll show them all and then we'll do a clean one after. So I'm going to deal with my H first. Everything goes to the right 45 degrees. Oops, that's not 45. This is. My 1 goes over 45. 180 goes 45. 270 and 360. This is our H. Just our H. Next, we're going to move a K value. K value was up 7. So instead of being at 0, I'm going from the blue next. I go up 7. And it goes, still has the same idea to it. 90, 180. Each point went up 7. Okay? So from the blue to the green is shifting this thing up 7 units. Okay? We've gone up 7 units. We've gone to, from the black to the blue, we've gone to the right 45 units. Okay, we've gone in a positive direction 45 units because it's negative. The last one is going to be our amplitude. So it's going from green to red. This is still going to be these points because they're considered our zeros, remember? This gets stretched.
Yes,
Okay, so instead of being 1, this is 2, 3, 4, 5, 6. We go down, instead of 1, 2, 3, 4, 5, 6.
Only the peaks get stretched.
Only the peaks and troughs get stretched. The zeros stay the same. That's why I normally do the stretching first. So it goes down. So our red one is our final graph. Now, technically, this is very important. It comes down and ends somewhere, it looks like around 2. It does something like that, okay? And it would continue to go up. 2 over would be here.
How would it end at 2?
Sorry, that's the height. It's somewhere in there in reference to what we were doing, okay? So the red one would be our final graph. They wanted to know why the starting point wasn't 1, which was our lowest point. If you remember, each full movement took me 90 degrees. From here to here is only 45. So I'm only actually going halfway there. It's something like this. At negative 45, I would be at 1. That's when it'd be down there.
I thought we moved towards 45.
We did. So we've graphed this function. It's our red one. They ask us to sketch it. We've done that. Determine the range of this function. What is the range? What is the highest and lowest point?
It's 13.
13 is the highest and 1. So if I were to do the range in set notation, YER, because range deals with Y.
0 to 13.
So we go from 1 to 13. Okay? Determine the range. 1 is our lowest point. Down here. 1 was the trough, and the peak was 13. That's why it's the range of our Ferris wheel. Now, of this Ferris wheel, our amplitude, they asked us, we already discovered it was 6. That also means that's the radius of this circle. All right? Our amplitude is equal to 6. We know that because our A was 6. What's our equation of the axis in this one? Remember EOA? Yes, it's exactly what K is. EOA is equal to positive 7. That means that's the line running through the middle of our graph. So we'll put a little, make it green in this case. That's the equation of the axis. So, what if we were trying to find the domain of this function? X is every real number. Now, there is a beginning point. It goes from 0. We definitely know that. Okay? But what we don't know is, it never told us when this ride ends. Maybe it's a ride that continues forever. Okay? We've only drawn it to 450, so we can say it's between. We can say X is between 0 and 450, but in the question it never states that. So another option could have been XER. Yeah, you could put the infinity sign there. Sideways A, like that. Or, okay, these are all acceptable because we technically don't know when the ride ends. You can just say, oh, I hit it twice. You can put X is greater than, see that's a little different, 0.
Yeah, that would
Okay,
be easier.
that would be the easiest way to probably represent instead of the infinity, okay? Okay, 12D. It asks us what the height was at 400 degrees, okay? So when I look at this on the graph, 400 degrees, well, I'm somewhere before this line. I can't really tell, okay? So what we're going to do instead is we're going to go back to that equation they gave us. The equation they gave us at the beginning, which was our H, right? And we'll use, they gave us theta. Okay, remember it was theta is equal to 6 sine theta minus 45 plus 7. What we're going to do is 400 degrees is our theta. So we're going to plug 400 in, and we're going to solve on our calculator. It says in the question they want to know how far it is after 400. So we take 400 and we subtract 45. I then put that to sine. I multiply it by 6. And then I add 7. So the height at 400 degrees would be 6.47 meters above the ground. I want to relate this to the beginning of the question because remember we didn't actually know exactly where it started. This will be probably one of the hardest parts. Let's say h theta. We want to know when x is 0, okay? When it hasn't moved at all. So our theta in that case is 0. Sine theta minus 45 plus 7. We're going to plug 0 in for theta. So we get 6 sine 0 minus 45 plus 7. To solve this one, we do 0 subtract 45 gives us negative 45. Sine function times 6 plus 7. That is the height. So when you get on this ride, you're starting 2.75 meters above the ground. And that's why I said we didn't quite know by looking at the graph because it was hard to put. We knew it was a little over 2 in this question. Let me just get both up for a second.